Flack math! Give me some math and I'll give you some flack. Flack math!
We're going to talk about just sign numbers. We talked a little bit about this, but let's just throw some examples on the board. Oops, that was a terrible I'm embarrassed. What do I get when I add these together? What?
And all the circle, half circle things, parentheses.
What should we do first?
Multiply and divide.
Multiply and divide, order of operations, right? So let's underline these and this. So I'm not going to touch this at all. -2 plus, what do you get when you multiply these two together? Grady? Positive 4. So this is just the 4. And then what do you do when you divide those two? Hunter? -1. Remember, 2 divided by 2 is 1. But a negative divided by a positive, you have unlike sign, so that's -1. Okay? So -2 plus 4. And then what's this? Minus -1. Remember, what do you do here?
You did the Bok method.
The Bok chicken scratch method, that's right. Bok. So that ends up being -2 against these two armies.
Which is 5.
So that's 5 fighting against a -2. What's going to be the outcome?
3.
+3. Okay? So this is just using both types of rules. We're multiplying and dividing sign numbers. We're also adding and subtracting sign numbers. Okay? So when it comes to subtraction, how do you subtract sign numbers? The answer is you don't. Change it to an addition problem because it's a lot easier. Okay? Let's see. Let's try another one. Simplify each term, then combine like terms. Okay.
What?
Whoa, this looks complicated.
Oh God.
Oh wait, sorry, this is not right. This is what I'm doing. Okay.
Is it -4 or?
Good question. So now it's just 2 -4, so that means 2 minus 4. But if there was parentheses there, then it'd be 2 times -4. It's kind of weird. All right, let's see if you guys can get this. Should we shoot for a free problem set?
Ooh, you could, but I would say that. I was going to do something. I forgot what it was.
What'd you get? Nope.
I haven't even pulled out my paper yet.
That's all right. Take your time. It's like the whole tortoise and the hare. Take your time. Do it right. hard to do it in your head. I think you can do it in your head, but it's just harder. All right, so
I wrote down the problems.
There.
It took me that long to write down the problems, so.
that's okay. Addie, you're in trouble.
Yeah, I know.
Why? Why do you have so many free problem sets? There's just no point in having them.
Use them.
So I did yeah, we'll have to figure out a creative way for you to use those.
You could,
Nope.
she could sell them.
Yeah, I could sell them.
Yeah, except Flack tags are not transferable or refundable.
Well, I have like 11.
It's the thing, it's in the contract.
No, you have 55. Because
Okay, what do we do first?
11.
Yeah.
Parentheses.
Okay,
Yeah.
now, technically, there's just one parenthesis, but look, this is also considered a parenthesis. So we just have to do this inside here, inside this parenthesis, and then inside this parenthesis. This is already done, but what? Let's do that. So I'm not gonna touch that. -3. What's this?
-2.
-2. So I'm gonna put parenthesis -2. Everybody okay with that? All right. Minus. I'm not doing this yet. I'll probably do it next. And then what's on top here? What's -3 times another -4?
Positive.
Positive 12. All over 2. So far, so good? Okay, good. What do we do next? Multiply and divide. Let's do this. Let's do this. And let's do this. What's -3 times -2? Positive 6. Remember, a negative times a negative is a positive. And what about, let's see here, we're multiplying 3 things together. What's 4 times -2 times -3?
Negative. Oh, wait. Positive 24.
Positive 24, okay? Remember that negative times a negative becomes a positive. 6 times a positive 4 is 24, okay? 24 plus 12 divided by 2 is 6. So when you do that math, -18 plus 6 is -12. Okay, it's complicated. And sometimes, I'll be honest with you, sometimes it's easier to do it in your head. And not easier, like, it's harder because you have to keep track of more in your head. But sometimes when you write it down, if you don't write it down correctly, it's gonna screw you up, right? So make sure if you write it down, and I'm glad that you copied the problem down right first, then just underline what you need to do first. Don't touch anything else, okay? Or you're gonna get into trouble. All right, let's do one more. And then we'll call it, that last one seems easier, but oh well. Here's example 3. I'm gonna write it right here. -2 minus bracket, parenthesis.
What's the other bracket?
Other brackets on the end there. Can you see that?
Well done.
Inside the bracket is parenthesis -3 minus parenthesis -4 times parenthesis -5.
All right.
What's that? What is that?
This?
Funny? What is it? Oh, it's fishy.
Mr. Flack.
Nope.
Oh.
Who's got
I
it?
did something wrong. Mr. Flack?
Yep, that's a -5 inside that parenthesis. It was just hard to write it that small.
Maybe.
Nope. Nope.
What?
Nope.
What? I have to
Ooh,
figure out
I'm
what I
really
did.
stumping you guys.
I have to figure out what I did wrong. Fine.
Uh-huh.
What?
Oh, no. So when you make that stretch, you change that sign, not that sign. You change the next sign, not the one
Yeah.
before.
There's the one at the very end. That's a 5.
But nobody's got it yet.
So that
Still open.
20.
Yeah. You don't want to show off.
Oh, wait, I think I figured out why.
What's that? Who, what, where?
I think I might have figured it out. I think I figured out what I'm doing wrong.
Okay.
I can't figure out what I'm doing wrong. I'll write it down and see.
It's a tricky one. Yeah. Nope. I'm really stumping you.
You liking it?
Nope.
Oh, I did it wrong. Yes. I did it wrong too, and I can't figure out what. Oops, I need electrical. Here we go.
All right, you can't even see it from where you're sitting. Huh.
You keep getting the same answer.
Yeah.
But no, not the same one. But I know it's wrong.
No.
This is confusing.
Did I tell you?
Yeah.
Wait, no, wait.
All right, we're gonna give Grace 30 seconds.
Wait, Mr. Flack?
What'd you get?
-66.
Nope.
How did you get -66?
Yeah.
There's all kinds of answers flying around today.
Hold on, let me try one more time.
What'd you get?
That's 3.
Nope.
Wait, hold on. Let me try one more time.
Grady, 30 seconds.
I officially give up.
What'd you get?
-19.
No.
Oh, there's minus sign like that.
Oh, I figured out why. Oh, wait, did I? Oh, wait, did I? Wait, is that 4 -4?
Yep.
Is it
-4 and a -5 in there.
Okay.
I'm happy that you can't get it because I feel like I've stumped you, but that's not a good thing. Like, if you're not getting it, then I'm not doing my job.
But
But it is fun to like you say, riddle and no one can figure it out. But I don't know.
But how? How is it not?
I can get the same thing. I can go.
That's very close.
I'm close.
Yeah.
But what am I forgetting?
I'm still
So you and Grady got the closest. What
Do we
did
get a
you
point
end
for
up-
that?
What was your final answer?
25.
Yeah, so you both got the same thing.
You
Okay.
get 3 problem sets for getting close?
Yeah.
Well, you know what you did? You think this -2 just became a +2 all of a sudden?
But you box bucket.
Yeah.
No, you don't balk before it, you balk after it. When you subtract, you don't do this. You do this,
Oh, you can only go over. Oh, whoa, wait, let me get the answer.
okay?
Oh. So that would be. Would it be
Is it, wait, hold on.
What?
Is
15?
it positive
No?
Y? No, positive
Oh, so
21?
You got
that is so annoying.
it.
Positive 21. Wait,
Okay,
how is that?
all right, watch this, guys. So what do you do first?
You do the brackets.
You do that inside the parentheses, right? If there's parentheses inside parentheses, you do those innermost parentheses first. The only thing we're doing here is -4 times -5. What's that?
20.
20, okay? So not -20, but 20, but you're subtracting 20. So it will eventually become -20. Okay, so this is what we got inside the brackets. We still have this -2 who's not gonna get any action until we're done with those brackets. Okay, so now we balk, right? we're going to Bach, negative 3 minus 20. What's negative 3 minus 20? Plus negative 20, right? Don't go backwards. Don't make that addition and Bach that. It's only what comes next, okay? So what's that add to?
23.
Negative 23. Remember, when you add two negatives, it stays negative. They're combining armies. But when you multiply two negatives, it becomes positive.
So annoying.
I know. Just one little thing will throw it off. Now what?
I stare at it and glare at
Yes. And then what? After you stare and glare.
Bach.
Bach. So plus positive. Remember, when you change it to subtraction, you change the next sign. If it's already negative, turn it back to positive. But it's still just 2 marks, right? So what happens when these guys fight? Positive 21.
Oh, sorry.
Right?
Yeah.
Little things, those cute little negative signs, even though they're very small, they will mess you up. Okay? So be careful. All right, the last part of this, for some reason, we started talking about functions in this chapter.
What?
Did we talk about functions yet?
Yeah.
Did I tell you about the big cardboard box that people spit into?
Yes.
Okay.
Yes.
All right, well, this is a function. So let's see if you guys can fill in the blanks here, okay? So here is a function. I like these. You get to figure out the pattern.
Lord.
Okay, what's that going to be?
Well, if it's,
You know?
that's easy.
What? Yep, yeah, it looks like it's doubling. So it could be several things. You could maybe multiply this by 4 and subtract 6. I mean, that's an option, right? That'll be really weird and probably won't be the answer. But just see what each of this could be. The most obvious one is either add 3 or multiply by 2. Well, adding 3 to 0 doesn't make it work. But when you multiply 0 by 2, it stays 0. So this could be multiplication. Because 4 times 2 is 8. 7 times 2 is 14. Good. All right, let's try another one. Here's our function.
Ooh, we get to make up the number.
What do you think's happening there? Grady?
You subtract 7.
Okay, so, yeah, so let's say this is 0.
7.
Right. Good. Can you guys handle these problems?
Yes.
Figure out the function and fill in the blanks. Okay? All right, well, let me give you a function, and then and I'll give you the left side, and you need to fill out the right side.
What? But how?
I'll show you.
We get to make it up.
So this one, if I were to write the function, what is this function? This is like if these are your x's and these are your y's, then y equals x minus 7. If these were your x's and these were your y's, then y equals 2x. You're just doubling it, right? So whatever you put in this function, those are your x's. It's just going to multiply by 2 to get your result. Okay?
Oh, I know.
Look at this. Y equals 2x plus 1. Okay? So we're going to try a function machine, but instead of drawing the machine, here's the function machine right here. Here's your x's and here's your y's. So give me an x. What's the easiest x to pick ever?
1.
7 is not the easiest, but we're going to pick 7. What happens when you put 7? What happens when you put 7 inside this machine? What's going to happen? Adeline?
You can multiply it by 2.
And then,
add.
yep, so what do you got?
Let's see, that would be, my brain's working.
Does this annoy you when I do that? So like, I'm waiting. Anyway, okay, so the easiest one, you all said 1. That's the second easiest X to pick. What's the first easiest?
0.
0. When you multiply by 0, what happens? It's just 0 plus 1.
1.
So when you plug in 1, you get 2 times 1 is 2 plus 1 is 3. 2 will give you 5 and so on. Okay, so that is algebra right there. So we're going to be doing a lot of that in algebra. We're going to be doing a little bit of that in pre-algebra, but a lot of it in algebra. Okay. All right.
All right.
So if this is on a test, a question like this, it might give you the X's to put in. Then you have to come up with the Y's. Okay. All right. Let's do 86. Okay, we are going to talk about number families. Okay, really these are just subsets or subgroups, subsets of all real numbers. Okay, we've already talked a little bit about some of these numbers. We've talked about counting numbers. Do you remember what counting numbers are? Yeah, numbers you count with, right? You got counting numbers, which are these guys, right? You got 1, 2, 3, and so on. What are whole numbers?
1, 2, 3, 4, 5, 6, 7, 8, 9. Anything above 0.
Anything including or above 0. So the only difference between whole numbers and counting numbers
is a 0.
Is a 0 or a big hole. That's how I remember it. Whole numbers have a hole in it. Okay? Are basically counting numbers with a hole in it. Okay? Then the next group of numbers are called integers. Now, we've already been talking about this without you knowing it. This is basically all the negative whole numbers.
What? 8, 3, 2, 3, 4, 0, 1, 2, 3, 4.
Right? So this time there's ellipses. These ... things are called ellipses. There's ellipses on both ends. So it goes both ends of the number line. But what numbers are we missing here? What numbers are we missing? Yeah, in between the fraction or what we call them, another word for fraction sometimes is ratio, right? These are called rational numbers. Rational numbers are any numbers that you can write as a fraction.
Can you write like any number as a fraction? Yeah, technically.
Yes. So all these numbers are rational numbers. All the numbers above it. Because how do you write 2 as a fraction? Put it over 1. Just throw it over 1. All these numbers can be written as a rational number. So all of these are rational numbers. All of these are integers. Because I see the counting numbers and whole numbers in there. All of these are also whole numbers. Okay? Now, here's what happens. Do you guys know what a Venn diagram is? Yeah, it has circles within circles and things like that, and then sometimes they overlap. Well, inside of this big thing, these are all of our real numbers. All of our real numbers. And inside the real numbers, there's only 2 sets. These are irrational numbers. We're going to talk about those later. Irrationals are numbers like pi or the square root of 2 or some numbers like that. Don't worry about irrational numbers now, but on this side, we've got rational numbers. We got rational numbers, so we got like 3/4. We got -1/2. We got a bunch of those numbers over here, right? But inside the rational numbers, there's another box. Those are the integers. Okay, but these are all still rational numbers, right? Because you can write -2 as a fraction, just -2/1. And then you've got your whole numbers, where you got the 0 in there, and then inside that box you've got your natural numbers or counting numbers. Okay, and that's where you get all the 1, 2, 3, and so on. All right. So this is a Venn diagram, but do you see that this rational numbers are all these subsets, all these families? Okay, so every single integer is a rational number. Every single whole number is an integer, and it's a rational number. Every single natural or counting number is a whole number. Every single counting number is an integer. Every single counting number is a rational number. Okay? So if it's inside the box, then it's true. You can do that with a lot of things. Like, for example, you've got, let me just draw a circle because it would be confusing if I drew a rectangle. But you got quadrilaterals. So, you know, quadrilaterals, it could be like a parallelogram. It could be like a rhombus or things. But then inside your quadrilaterals, you got rectangles. But inside the rectangles, you got squares. Because every single square is also a rectangle, but not every rectangle is a square. Okay? All right, so when you graph, have we done graphing on a number line yet?
Yes, yes, we have.
So when I say graph x is less than 4, have we done that yet?
Not that, but
You know how to graph that?
yeah.
How? With a number line. What?
That's what I was gonna say.
Okay, so how do I draw that on a number line? So how do I graph everything less than 4? Yes.
So you're gonna shade, no.
I know.
You're gonna circle 4.
Yeah.
So just
Have we talked about this, or did you learn this somewhere else?
No, yeah, I remember you teaching.
Okay, yeah. So remember, we're putting an invisible force field around 4 because we don't want to touch 4, but we want to graph, we want to shade everything less than 4. Do you guys remember doing that?
Yeah.
Okay, now what if I just want to graph the integers less than 4?
Well, then.
So I'm going to draw my number line on here again. What if I wanted to just graph the integers less than 4? What do I do?
Oh,
No?
I have guessed.
Okay.
You shade all the negative numbers. Less than
Okay.
4.
Well, remember, all the integers are positive numbers too.
Then you shade everything less than 4.
So just like this?
Yeah.
But see how we're shading like 2.5 and 2 1/4. We don't want to shade those. Okay, so you're getting there. You're getting closer. So we just want to shade the integers, or we just want to plot the integers. So we're just going to put dots on all the integers less than -4 or less than 4. What integers are less than 4? Adeline?
3, 2, 1, 0, -1, -2.
Yep, and keep going because they're integers. Now, if I just said graph all the counting numbers less than 4, what would you do? What?
Just do 1, 2, and 3.
Just 1, 2, and 3. If I said graph the whole numbers less than 4, what would you do? 0, 1, 2, and 3, right? So this is basically, this is restricting what kind of numbers they want you to graph. So that's called their domain. These are the only numbers that go into it. 3, so all the integers. So what integers are less than 4? Well, 3, 2, 1, 0, -1, and anything, and all the integers below that. Okay? Does this make sense? All right, good.
Black math, give me some math and I'll give you some flack. Black math.